Hello, so this is the demo for TensorFlow, how to use TensorFlow for the basics of it and how to use it in neural network training. So yeah, so this is similar to PyTorch, but it's another library. So in this notebook, we'll just deep dive into the fundamental building blocks of it. Yeah, so it's for installation. You just have to install TensorFlow. Excuse me. um, yeah, again, TensorFlow also uses GPU, so I had connected it to GPU, so it recognized it, and later it will use GPUs. So again, as I have already mentioned, that higher dimension data is whenever we are dealing with feeding data to neural network, we will be sending the data in tensor format. It is a multi-dimensional array, and a generalization of scalars, vectors, and matrices to higher dimensions. So yeah, say a scalar value will look like this, a vector is this is a 2D matrix, and a 3D tensor looks like this. And why tensors is because it can it can be um, mm, the data of higher dimensions can be stored via tensors. Like images are 4D, and we can create 4D tensors. Video data is 5-dimensional data, which has batch, frames, height, width, and channels, like that. So if we're creating, we just have to scalar value can be initialized using constant excuse me, and the value of the scalar. And yeah, again, here you can see its shape and its dimension. So as it's a scalar value, there's no shape, and dimension is 0. This is a single vector. Here you can see the value of vector, its shape, and its dimension. Again, this is for 2D matrix. This is a 2D matrix. Its shape is 2 cross 3, dimension is 2, same as 3. So the shape is 3 cross 2 cross 2, and the dimension is 3. Now to visualize tensors, yeah, this is how a single vector scalar looks like: a vector, a 2D matrix, and a 3D tensors. Then again, it has some special operations, like you can create a tensor of all zeros, all ones, and fill is basically what value you want that tensor to have. Then identity matrix is also, again, here it's I, and this is the dimension, so it will just give you a 4 cross 4 identity matrix, which is a diagonal matrix with all ones. And this is so basically this is linear algebra and diagonal, so you can provide the values of the diagonal. Here in I, it is always 1, but when you want a matrix which has some values in the diagonal, you just use this one. And again, it has a range function, start, stop, and step, like line space to get a vector with evenly spaced values. Again, a random function here, it's there. If you want a uniform distribution, you can specify uniform. It can also give you a normal distribution and a truncated normal distribution. Excuse me. Then weights initialization. So as we do in PyTorch, we just randomly initialize the weights. So we are initializing the weights in a normal distribution, centering around an average. And we can also use keras initializer function to initialize the value using uniform distribution or normal distribution. Yeah, that is pretty much it. So here it has initialized a vector of shape 284 by 256, 784 by 256, uniform distribution and normal distribution. So Yeah. So this is how the Xavier or Goldratt distribution looks like, and this is the normal curve, and this is the uniform distribution. And here also we have different data types like float 16, 34, 64, 30, int 32, int 64, boolean, and string. um, yes. Then we can do typecasting here. For typecasting, it's just this function cast the original and the data type you want it to change to. Then you can also look at the memory usage of each data type. So as it's obvious that float 64 will have more memory, and float 16 will have lesser. So yeah. Then there are different attributes to tensors: shape, n dimension, data type, and device. So yeah, shape gives you shape, this gives you a number of dimensions, data type, and the device, whether it's using GPU or CPU, like that. Yeah, so converting between tensorflow, numpy, and python. mm. So we can create tensor from numpy array, a normal list also, uh, and this constant is just, it gives you the scalar value. Then important operations work on numpy too. So hmm. Yeah, again, indexing, slicing, and reshaping is possible using TensorFlows. Indexing is same. Just give the number that is the index of the tensor. You can also slice it. I think that should be somewhere here. Yes, we can also slice them using colon, and yeah, that the syntax is same. You have to just give the start, stop, and step. Step by default is always 1, and stop is always excluded. Yeah, that is pretty much it. Then it has gather and gather nd. So when you need to extract elements at specific indexes, use these functions. Excuse me. Yeah, gather nd is for multidimensional indexing. So you just provide the matrix and the coordinates you want to extract, and it will do the work. Again, here Boolean masking works well. It is very useful for filtering the data by a condition. So like we did in numpy and pytorch, yeah, it is the same. Then we have reshape operations to change the shape of a vector. So let's say this is a single vector with all these values, and I want to reshape it to original. Original is this value, and shape I want it in this shape. So if you can see, sorry, it reshaped the same vector into different formats based on the dimension shape I have mentioned. So yeah, that is also possible. um, mm, Excuse me. Then again, it supports transpose, so you can calculate a transpose of a matrix. So basically this transpose will be 1 4, all the rows will become columns and columns will become rows. That Then expand dimension is add a dimension of size 1. So expand is adding a dimension, and squeeze is removing a dimension. So that is also possible over here. Then again concat and stack is also available here. You just concat one after another, and stacking is can be one after another or one on top of another. So that is also allowed. These are the examples given. So yeah, concat joins along existing axis. Stack is creating new axis when joining, which we have discussed in the PyTorch explanation. Then element-wise operations are also available. So PyTorch and TensorFlow can be used already, interchangeably. They give the same operations, just the syntax is different. Excuse me. Then the mathematical functions like exponents, log, square root, square, power, all these can be used. Angles, the radians angles like sine, cos, tan, all the trigonometry can be done. Again, it has activation functions like sigmoid, tan, relu, tikirelu, gelu, like that, and softmax. It's just plotting how it looks, which is the same as what we have learned. Again, it supports broadcasting. Here you can see the excuse me. And broadcasting in all the levels in a singular level. If the uh, whatever, if it's a single value, it will get added to every value of the matrix, like that. Then it supports matrix multiplication. It has to the syntax is like this: df.matmul, and just give the two matrices, and it will give you the output. And excuse me. At the rate, again here also at the rate works. Matmul function is an alternative to it. So whatever, you can use both of these. All the the output will be same. Then other metrics vector operations like dot product is also allowed. Let me show you. This is tensor dot. This is how we can use and give the two the vectors which you want to do dot product, and it will give you the output. Then again, norm can be calculated. L2 norm, Manhattan, L1 norm using a Manhattan distance, and this maximum absolute value. So again, earlier we used to give here you have to give the order as 2, the order as 1, so L1, and order is infinity, means maximum absolute value norm. So then again, here you can give take out the eigenvalues and eigenvectors. This is basically used for dimensionality reduction. Then single single value decomposition is also we can do, and the Einstein summation, so combining multiple operations into one and doing it is also possible over here. You just have to give it is same as what we did in PyTorch. Just give the what you want, what operations you want, how the input will and how the output will look, and the metrics, and it will give you the output. So these are the different the same thing is there, this table. So where you just see what this means. It's sum over rows, sum over columns, matrix multiplication, dot product, transpose, etc. So it is very much similar to that. Just a simple short syntax difference. Otherwise, everything is pretty much the same. Here I think we are creating a very dense layer. So we have this x, y, x is input, w is weight, and b's are bias. and activation. uh, yes, so we have defined our layer over there, and this is the operation we want to do. We want to first matrix multiply x with w, then do add the bias to it, and if activation is there we will pass it through activation, otherwise we'll just return z. So yeah, that basically our neural network is this. We are just initializing it and we're getting the output. Yeah, and again the losses are also same here, softmax and cross entropy loss. Cross entropy is for classification, root mean square is for mean square error is for regression problems. Yeah, that is, I think, these are just the examples of what and here it has implemented batch normalization. Yes. Hmm. It's just computing the mean and variance across batch dimensions and then normalizing it and returning it. This is with forward pass, neural network with forward pass. So yeah, so we are in this forward function we are defining how the sequence of the network will be. Yeah, so that is pretty much it for this video. Thank you.